Hello there, students of economics, and welcome to yet another teaching lecture in economics. Well, the topic we are covering at hand is presentation of data, under which we've already completed simple, multiple, and component bar diagrams, as well as we've learned to construct the pie diagrams, right? So we're moving on to learn about the next type of diagrams, which is frequency diagrams. Well, this is not really new to you, but we're going to adapt it to the study of economics. So are you ready? Come on, then let's go forward. In this lecture, we will study about frequency diagrams and their construction. So we will learn about the histogram, the frequency polygon, the frequency curve, and ogives, under which we will learn about the less than type of ogive and the more than type of ogive. All right, then let's begin. The first type of frequency diagram we will be learning about is the histogram. Now, a histogram is a two-dimensional diagram, of course, containing a set of rectangles, as you can see here in this illustration. At the base, the class intervals are seen along the x-axis or the horizontal axis. The area of the rectangle is proportional to the class frequency. The rectangles are adjacent to each other. As you can see, there is no space between two rectangles. Now, the histogram also gives us the value of the mode of the distribution. So the highest frequency would be the mode. And the histogram clearly gives us an indication of the mode of the frequency distribution. It tells us which class interval has the highest frequency. And now, moving on to the drawing of the histogram. Well, you can see we need class intervals to draw the histogram. You have wages in rupees given in the first column. In the second column, you have the number of workers. And so what we have to do is we have to indicate the wages on the x-axis. So you have here 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, and so on. And the number of workers is shown on the y-axis. Now, the lengths of the rectangles that are drawn will indicate the frequency. So you can see here 0 to 5, the frequency is 4. So throughout the class 0 to 5, we have to mark the frequency 4. Then we go on to 5 to 10. The frequency is 10. So here you are. 5 to 10, the entire class interval has a frequency of 10. And so on and so forth. Well, you have to understand here that the length of the rectangle indicates the value of the frequency. So as you can see here, what would be the mode? Therefore, it is so clear. The mode is 32, which is the highest frequency. So that means a histogram helps you to identify the mode of a particular frequency distribution. All right, then we have here a frequency distribution showing the number of students obtaining marks in a particular class interval or group. So you have 5 students getting marks between 0 to 10, 10 students obtaining marks between 10 to 20, 15 students getting marks between 20 to 30, and so on. And we'd like to represent this with the help of a histogram. So we indicate the marks or the class intervals along the x-axis. And we indicate or show the frequencies or the number of students, in this case, on the y-axis. So you have class interval 0 to 10. Entirely having a frequency of 5 number of students, 10 to 20 having a frequency of 10, 20 to 30 having a frequency of 15. So that means the top part of the bar really marks out the frequency, and you have the rectangles which are adjacent to each other. There is no space between the bars as in the case of a simple bar diagram. Now, on this particular diagram, we have also shown what is known as the frequency polygon. Now, the frequency polygon in this case has been drawn by joining the midpoints of the top part of the bars of the histogram. So the top part of the bar, the midpoint is taken, and those points of all the bars are joined You end it here on the point where 0, or rather you could even end it here on this class interval, that is -10 to 0. So this one is closed as well on the other side. So there are two ways that you can draw the frequency polygon. One is by taking the midpoint of the top part of the bars of the histogram. When we learn about the frequency polygon further on, we will deal with that later. So now moving on to the frequency polygon and frequency curve. A frequency polygon is a plane bounded by straight lines on all sides. Like you can see here, the frequency polygon is shown by the area under A, B, C, D, E, F, G, H. So this entire area, which is shown by the dotted lines, indicates to us the plane. Now, the method of drawing a frequency polygon is to join, as I told you earlier, the midpoints of the top sides of consecutive rectangles of a histogram. But you could also plot it directly. When you look at the midpoint of the class interval, the points can be plotted directly on top. Now, a frequency polygon can be used to draw the frequency curve. The frequency curve is obtained by drawing a smooth freehand curve passing through the points of the frequency polygon as closely as possible. So we will look at those diagrams in the next slides. Here we have a frequency polygon which is drawn with the help of the top sides of the consecutive bars or rectangles of a histogram. So here we have wages shown on the x-axis and number of workers shown on the y-axis. And as you can see, the midpoint of the class interval, you can plot your point there. And that is another way you can draw the frequency polygon and thereby join the points, even if you do it without drawing the histogram. And you end it at the midpoint of the first class interval, the previous class interval before the first class interval, and you can end it at the midpoint of the class interval that is after the last class interval, because we define the frequency polygon to be a plane figure, right? And here we have the frequency curve, which is the smoothened form of the frequency polygon. So usually we would draw with a scale and join the midpoints of the top sides of the consecutive bars or rectangles of a histogram. But here we draw it with a free hand, a very smoothened way of drawing the diagram, which also basically goes through all the points that we are concerned with, the midpoints of the top sides of the histogram. That is one way of drawing the frequency curve as well. Here in the second illustration, we have shown all the three: the histogram, the frequency polygon, which you see here, the darkened one, and the dotted line, we show the frequency curve. So that is the way I'd like you to draw in your Word document. I've put some frequency distributions and I've asked you to draw various types of diagrams, that is histogram, the frequency polygon, and the frequency curve. Moving on to the next type of frequency diagram, which is the ogive or the ogives. Ogives are also known as cumulative frequency curves. An ogive is a graphical presentation of a cumulative frequency distribution. In this method, the cumulative frequency distribution is plotted along the y-axis against the class limits of the frequency distribution, which are plotted along the x-axis. There are two methods of constructing ogives. One is the less than method. In this method, the points x and y are plotted. X represents the upper class limit of the class interval and y represents the cumulative frequency of the respective class in ascending order. These points are then joined with a smooth curve. Resulting curve is a less than ogive. Then we have the more than method. In this method, the points x and y are plotted. X represents the lower class limit of the class interval and y represents the cumulative frequency of the respective class in descending order. These points are then joined with the help of a smooth curve and the resulting curve is a more than ogive. Let us now convert the frequency distribution to a cumulative type of frequency distribution. So the same table or the same columns are taken and adapted to find the cumulative frequencies according to two methods. One is the less than method and one is the more than method. So what we have to do here is we ask the question for less than method, how many students get marks lower than the upper class limit, which is 5, or less than the upper class limit, which is 5. So you can see here in the table, less than 5, less than 10, less than 15, less than 20, less than 25, and so on. And so how do we derive how many students get less than 5? Obviously, from 0 to 5, the number of students is 3. So less than 5, the number of students is 3. Less than 10 would be all the students getting 5 to 10 as well as 0 to 5. So we have to add 10 to 3, which gives us 13. All the students getting less than 15 would be 20 plus 10 plus 3. So that gives us 33. Then 33 plus 30 gives us 63. 63 plus 20 gives us 83. 83 plus 9 gives us 92. 92 plus 5 gives us 97. 97 plus 3 gives us 100. So less than 40 you have 100 students. Now moving on to the more than method. So we are going to ask the question to the lower class limit. How many students are getting more than 0? How many students are getting more than 5? How many students get more than 10, more than 15, more than 20, and so on? Basically, all the students are getting more than 0. So that makes it 100. 100 minus these 3 are those students who get marks more than 5. So 100 minus 3 is 97. 97 minus 10 is 87. 87 minus 20 would give us 67. 67 minus 30 gives us 37. 37 minus 20 gives us 17. 17 minus 9 gives us 8. 8 minus 5 is 3. So how many students get more than 35? Obviously 3. Let's revise how we're going to draw the less than ogive. As you saw earlier, we spoke about how many students get less than the upper class limit, which is 5. That means when we're going to plot the points of the less than ogive, we're going to do it against the upper class limit. So here are the cumulative frequencies of the less than type of method. So we plot the frequencies against the number 5, which is the upper class limit of the first class interval. So you see here in the diagram, we have marks, of course, plotted or taken along the x-axis, number of students taken along the y-axis. 3, which is the frequency, that means those students getting less than 5, is plotted against 5. What is the question we asked? How many students get less than 5? And how did we find that out? Less than 5 are 3 students. Less than 10, 13 students. So we plot the value 13 against the upper class limit in that case, which is 5. How many students get less than 15? 33. So we plot the frequency 33 against 15. How many students get less than 20? 63. So we plot the frequency 63 against the value 20, which is the upper class limit. In the same way we go forward. And once we plot the points, all we have to do is join the points and we derive the less than ogive. Here we are now with the more than ogive. So how many students get more than 0 is the question we asked. How many students get more than 5, more than 10, more than 15, more than 20, so on. So in this case, in the more than type of frequency distribution or cumulative frequency distribution, we plot the cumulative frequencies against the lower class limit, which is in this case is 0. Here in the next instance it is 5 and so on. So 100 is plotted against 0. So that point would be on the y-axis itself. Now how many students are getting more than 5? 97. So against 5 we plot the point of frequency 97. How many students are getting more than 10? 87. So against the number 10 we plot 87. How many students are getting 15? 67. So that is the point we plot against the lower class limit, and so on and so forth till the last point, that is more than 35. the frequency would be 3, which is here. Now when we join all these points, what we derive is the more than ogive. Now here we have shown both the less than ogive, which is going upwards from left to right, and the more than ogive, which is going downwards from left to right. The left of our diagram is this side and the right of our diagram is on the other side. So both the less than ogive and the more than ogive intersect at a certain point. If we drop a perpendicular down, we will get the median marks. In other words, in this case it is about 18 marks, which is the median marks. So with the help of the ogives, we can identify or locate the median marks. Alright, my dear students, here is some homework for you. I'd like you to draw the less than ogive and more than ogive curve on the basis of the data given below. As you can see here, the variables are all concerned with economics. You have income in thousands and number of persons. This could also be profit, expenditure, wages, salaries, and so on. Well, what I want you to do essentially is draw the less than ogive and more than ogive. Let them be drawn on the same area or graph paper, and where they intersect, drop a perpendicular down and find out the median income in thousands. In this lesson, therefore, we learnt about the histogram, frequency polygon and frequency curves, as well as ogives, less than and more than ogive. Students, as always, I wouldn't like to leave you without a quote. Well, the quote here is, it's not necessary that every picture or diagram should be beautiful, but it should be comprehensive. The diagram should enable us to analyze, interpret, draw conclusions, come out to some policy making decisions or so on, which enables government, business enterprises, firms to analyze the data that they collect by means of surveys and thereby solve various issues or economic problems. So thank you, students, for giving me a listening ear. Please see that you complete all your work neatly and diligently. Thank you.